If you're seeing this video, it means the build actually compiled. Hey, this is Neoxider. This game already works, but look what happened to it after just a couple of edits, and what those edits ended up costing. That's what our experiment comes down to. First, let's agree on terms. Vibe coding is when I have an idea, and I hand the implementation over to the neural network. AI development is when I dive into the implementation myself. I set the rules, the technologies, the boundaries, and the checks up front. What's being compared here isn't two models, it's two processes. And to make this an experiment and not a show, I'm putting forward three hypotheses. Hypothesis 1. Vibe coding is cheaper at the start, but every next connected edit gets expensive faster. Hypothesis 2. With AI development, the edits stay local, boundaries and tests keep a change from spreading across the project. Hypothesis 3. For a growing project, AI development wins out in the end, despite the expensive start. At the end, I'll honestly confirm or disprove each one. But for now, pick your favorite. Both versions get the same task: build a local arena. A player, at least 3 hostile bots, identical weapons, health, experience, levels, and the right to attack each other. Real networked multiplayer stays a bonus. It has no right to replace the mandatory core with a pretty promise. A working result doesn't count as a screenshot or a green console, and no polished demos. Wherever the neural network screws up, I'll show it in close-up rather than hide it. The game has to launch, survive death and restart, and then accept the same new feature with no hidden manual help given to one side. In the first branch, the agent got the goal and the materials, but decided for itself how to structure the project. An important detail about the model, the whole foundation of the game, both versions, was built by the neural network Fable 5, and it laid down 2 different architectures. The identical edits and measurements, both branches ran those on Opus 4.8. I hit the limits on Fable. But the conditions are equal. Within each stage the model is the same, only the approach changes. At first it all looks convincing. Files appear, game systems, the first visual solutions. But the structure is still the agent's own decision. So the first real test isn't the amount of code written, it's launching the game. And it shows up. The slime moves, there are enemies on the arena, combat ends in death, and after leveling up you can pick a new weapon. This isn't a mock-up anymore, you can actually play it. Vibe coding's first local win is strong. An idea quickly turns into a living event, and this is exactly where it's easy to stop testing and say, done. But our main question begins right after that first success. What happens when the project has to be not shown off, but continued? Underneath the working picture, the price of improvisation shows up. Part of the balance is hardwired straight into the code as constants. The game classes are dumped into almost one flat folder. On one of the passes, the agent declares the core done, but the build greets us with an error. Further on you can see long conditional methods and bot logic on a chain of simple if statements. This doesn't prove that vibe coding always builds bad architecture. It only proves the state of this version. It already plays, but the next connected edit will touch some not very clear boundaries. And there's an important caveat. A good plan and a strong model can noticeably smooth this problem over. The more precisely you describe what to build, the less room there is for random improvisation. But a plan doesn't replace the decision about how to verify a change after it's implemented. So the second pass begins. Fixing the visual and gameplay shortcomings. Part of the interface gets better, but new small deads appear. Then the bots vanish, completely. Looks like they were the first to understand the price of the next edit and left the project. And when the remaining slimes gather around the player into one dense pile, it's already hard to find a technical term for it. It's just meat. The jokes here don't cancel out the fact. The version recovers and stays playable, but the fixes don't close every defect in a single pass. The final recording confirms the main thing. There's a start screen, weapon selection, combat, damage, death, statistics, and a repeatable gameplay loop. You can play this version, and that's a strong result for autonomous development. At the same time, the screen itself shows the limitations. Text overlaps the cards, individual interface elements are hard to read, the balance in places punishes the player harshly. Branch status, playable is proven, but quality and ease of continuation are limited. Now it's not enough to ask who showed the game faster. The first build already exists. The main test is a different one. How much will the same next edit cost? This is exactly where AI development has to justify the time spent upfront on rules and boundaries. In the second branch, the neural network gets more than just the goal. Before implementation, the architectural boundaries, technologies, tasks, and definition of done are all fixed. The game logic doesn't depend on the engine, so it can be changed and tested separately without touching everything around it. The connections between the parts are gathered in one place, and every finished feature has to pass a check right there in the game. This is still only a plan, not proof of quality. Folders and test files by themselves guarantee nothing. So next, we check not the presence of trendy names, but whether the boundaries hold up in the real code. At every checkpoint, this branch has an owner, an acceptance criterion, and one next step. But the process doesn't turn the agent into a flawless developer. The check is needed precisely because a rule can be written down and still get broken. If the check catches an error, that doesn't become a success, but its spread is stopped. The feature goes back for fixing. Even in the controlled version, the architecture is far from ideal. In places, the agent left methods too long and mixed up responsibilities. But there is one telling contrast. And it's not about hacks, the scans are clean on both branches. It's about debt. The Vibe version was left with debt on a distant horizon. For example, an unbounded spawn queue that would have grown over time, and experience growth inflated by roughly double. AI development closed that same queue right away. In total cost, this long run of the second branch turned out more expensive. But in that same session, music and sounds were being generated, and the limit ran out 3 times with a memory reset. That's the price of one specific run, not the normal price of one feature. So next, I'm not comparing this long session, but identical edits, each in its own clean session. That's exactly how I ran the identical edits on both versions, and here are the measured points. The hypothesis was this: VIBECODING is cheaper to start, but the cost of connected changes grows faster. On the first edit it all lined up, VIBECODING came out cheaper. But by the third identical edit, the picture flipped. For VIBECODING the edit got about twice as expensive, for AI development by less than a fifth, and it's not growing by chance. With VIBECODING, every change touches a class that has ballooned to hundreds of lines and doesn't have a single test, the edit drags the neighboring code along with it. With AI development, the boundaries between layers and the tests keep that same edit local. An important caveat: these are 2 or 3 measured points, not a textbook exponential. The direction is unmistakable, the curves crossed, but the exact shape of the curve years out isn't proven by these points. This is a fact about this one project, not a universal law. A mixed outcome. VIBECODING was faster and cheaper at the start to produce the first prototype, but AI development ran the identical edits cheaper and handled the continuation better. On the third edit, VIBECODING's cost overtook it, those very curves that crossed. There's no absolute winner. For a quick test of an idea, VIBECODING wins. For a growing project, AI development, the decisive proof is the cost of the identical third edit. The strongest counter-argument against AI development is that it started more expensive and isn't perfect itself. And this is the conclusion of one project on one line of models. At another scale, the crossover point will shift. A practical rule: for a quick test of an idea, VIBECODING is often enough, especially with a precise brief. For a growing project, you need boundaries, criteria, and human acceptance. But this architecture isn't universal. The stack depends on the team and the project, and written down rules don't guarantee good code. And it's not just my one project. Large analyses of real commits and developer surveys record the same direction. With artificial intelligence, code duplication grows while refactoring and stability sag. But no one has proven the exact point when the debt will catch up to your specific project. That stays my experiment. And only now, the last chart, the raw total cost of the whole experiment. VIBECODING $208, AI development $741. More than 3 times as expensive, so Vibe 1, don't rush. This is the trap of raw numbers. In that long run of the second branch, in the same session, music and sounds for the game were being generated, and the model's limit reset the memory 3 times, so the context was rebuilt from scratch each time. The honest metric is the cost of an identical edit in a clean session, and there the curves have already crossed. The verdict on the hypotheses. The first, Vibe is cheaper at the start, but the edit gets pricier, confirmed. By the third edit the cost had doubled. The second, edits stay local with AI development, confirmed. Boundaries and tests held the changes in place. The third, AI development is more profitable for a growing project, confirmed on the cost of edits, but with a caveat. On the raw tally this run is more expensive, and I'm telling you that honestly. And here's the conclusion that matters more than any number. The Vibe version piled up a lot of bugs. An unbounded spawn queue, experience growth inflated by double, I showed them earlier, and those are only the ones that surfaced. The AI development version had bugs too, but non-critical ones. The architecture and boundaries set up front kept them local. Not a single one broke the game. From this comes a simple takeaway. On a large growing project, AI development wins for two reasons. The first is control. A thought-out architecture and approach give fewer bugs and predictable edits. The second is money. The further the project goes, the cheaper every change in it becomes. Vibe coding is dazzlingly fast at the start, but the bigger the project gets, the more it ends up costing. The source code for both versions I'll leave in the description after a final check. And now it's your move. Write in the comments what to test next. Take the arena all the way to real networked multiplayer, run the 4th and 5th edit and see whether the curves diverge further, or pit two different models against each other on this same process. Whatever gets the most votes becomes the next experiment. And to finish, let's just play, no editing, no background music. Everything you're about to hear, the music and sounds of the game itself, was also generated by neural networks locally in that very same long session that blew up the bill of the second branch. First, the Vibe version. Notice how fast the levels rack up? That's the experience growth inflated by double. From here, just listen and watch how it plays out live. And this is the AI development version. Same task, same arena, a different architecture under the hood. Listen to the sounds. Every effect here was also born from a text description. It plays smoothly, no critical glitches, exactly how it should be when the rules are set up front. That's all for now, see you in the comments. Don't forget to save. See you in the next build.
Слайм моргнул, подпрыгнул, ой, ну раз включил, летим со мной. В мастерской был образцовый порядок, каждый пунктик подписан и спрятан. Но зеленый герой покатился вперед и случайно собрал звездолет. Вместо кресел пружинный диван, вместо карты рисунок банан. Нам твердили, такой аппарат не взлетит, но уже через миг он над городом мчит. Раз проверим тягу, два запишем звук, три и новый космос зажигается вокруг. Neoxider, время создавать. Neoxider, новый мир запускать. Прыг-скок через звезды за горизонт. Если нету дороги, построим мост. Neoxider, некогда скучать. Будем думать, пробовать, изучать. Пусть не все получается с первого дня. Каждый новый эксперимент меняет меня. Мы нашли планету пружинных камней, где предметы взлетают сильнее людей. Там деревья растут корнями вперед, а зеленая речка по воздуху льет. Слайм хотел взять образец и прилип, потянул за собой исследовательский клип. Мы смеялись, но все записали в журнал. Липкий грунт, очень прыгучих дыхание сдать. Раз измерим точно, два запишем звук, три и новый космос зажигается вокруг. Neoxider, время создавать. Neoxider, новый мир запускать. Прыг-скок через звезды за горизонт. Если нету дороги, построим мост. Neoxider, некогда скучать. Будем думать, пробовать, изучать. Пусть не все получается с первого дня. Каждый новый эксперимент меняет меня. Если кнопка красная, сначала прочитай. Если все же нажал, наблюдай и записывай. Если выросли крылья у старых часов, значит время готово для новых миров. Не страшна неудача, когда ты поймешь. Даже странный итог на находку похож. Слайм кивает серьезно секунды на две, а потом снова скачет по всей лаборатории. Neoxider, время создавать. Neoxider, новый мир запускать. Прыг-скок через звезды за горизонт. Если нету дороги, построим мост. Neoxider, некогда скучать. Будем думать, пробовать, изучать. Каждый опыт стукается с первого дня. Мы не знаем, что выйдет, и в этом весь ад. Как на кнопку шлеп в портал. Кто в приключении начинал? Слайм смеется, это я. До следующего мира, друзья.